Okay, guys, so here, like I said already, I'm hoping that you noticed that while you were writing these down, is that these two theorems are converses of each other, right? So the first one is saying a line from the center of a circle. So here you can see point O is supposed to be the center. Looking at it now, it's not. But anyway, I didn't draw it very accurately, but it's supposed to be the center. A line from that center perpendicular to a chord. Does what? It bisects the chord. Alright, so this is the condition. The fact that it is from the center of a circle and that it is perpendicular to a chord. Then the result is that it bisects the chord. It cuts that chord in half. So that is what we are going to use this theorem for. If we can see that we have a line from the center and it's going to a chord, then what does it do? And it's perpendicular to that chord. Then what does it do to the chord? It cuts it in half. So guys, you'll see in the worksheet that we're going to look at, often they'll give you the length of AB of the whole chord, right? And then what you must say is that AC is a specific length or BC is half. All right, so that's what we're going to use it for, to actually get the lengths of those parts there at the bottom. Okay, you'll see when we get there. The reason that you need to memorize, please, line from center perpendicular to chord. Okay, very self-explanatory. It's basically what the theorem says. It just doesn't include the result of the theorem. Okay, so the reason doesn't include the bisecting part. Why doesn't it include that? Because that is in your statement that you have that. Okay, so you don't have to put it in your reason as well. Now guys, the second one is saying just the opposite. Now if you again have a line from the center of a circle, but now it's going to the midpoint of a chord. Right, so they are telling us that this line bisects the chord. Then what happens? It is also perpendicular. So it's just the opposite of the previous one. Okay, so here the condition is, again, it's from the center of a circle. And then it is to the midpoint of a chord. That's the condition. So that is the information that they have to give us, right? It's going from the center and it is going to the midpoint of a chord. Then what is the result of that? It is perpendicular to that chord. Alright, so that is what we are using this theorem for. When we need to show that that is a 90-degree angle. That's what this theorem is used for. They're telling us that it's going to the midpoint, it's bisecting the chord, and we are then going to state that that is a 90-degree angle. Yeah.
Why did you do other things?
They can mix them together in a question as well. You'll see in the worksheet. Okay, sometimes you have to use both in one question. Okay. Now guys, instead of saying that OC is perpendicular to AB, you can also write it slightly differently. You can say that angle OCA is equal to 90 degrees. Or you can also say OCB is 90 degrees. Alright, depending on which angle you need. You'll see now when we do an example. And the reason there, again, basically what the theorem says, line from center to midpoint of chord. Is your hand up?
In some examples, like the joint OB and OA, so will there always be right angle triangles?
Yes, if we have that these two parts are equal, yes, then it will be a right angle triangle, but then you must first write that.
So you have to use that if you say it's right.
Yes, yeah. Okay, let's look at that worksheet, guys. I want to do the first, we have 10 minutes. I want to do the first one or two examples with you. So that is now the worksheet that I handed out earlier. All right, this one that says midpoint chord theorem worksheet, that one. I just quickly want to open it up here. All right, if we are looking at that first question, they're telling us that O is the center of the circle. AB is perpendicular to OC. All right, so there they are showing us, what is this line? It's a line from the center and it is perpendicular to the chord. So what does that mean, guys? If you have a line that's perpendicular to the chord, it's going to bisect. It's going to cut it in half. So we can already fill in on our diagram that those two parts are going to be equal to each other. Okay, that is using the first theorem that we wrote down, number one. Line from center, perpendicular to chord, it cuts the chord in half. All right, let's see, what else did they tell us? OA is 50 millimeters, so let's fill that in. OA is 50. Now guys, what type of line is OA? It's a hypotenuse of the triangle, yes, but in terms of the circle, it's a radius, right? So if we have to draw in a radius at any other place on the circle, then it would also be 50. So I'm just going to add that in. This is also the radius. So if we needed, for example, to use OB, right, and we could then obviously draw in OB, and then that would also be 50 millimeters. Because remember, radii of the circle at any point on the circumference are always equal to each other. Okay, they are also telling us that OC is 30 millimeters. OC is this line over here. That line is 30. Now they want us to calculate AC. Right, now what can I use to calculate AC, guys? Pythagoras, right? We don't even need circle knowledge to find AC, guys. They told us that length, they told us that length. We know that this is a 90-degree angle, so we can use Pythagoras. Okay, so I'm just going to do the working here on the side because I want you to see the picture. So we're going to say AC squared is equal to, now guys, is AC the hypotenuse? No, so I'm not going to add the other two together, right? I'm going to take the hypotenuse squared, and I'm going to subtract the other one also squared. Please remember, you have to write as a reason Pythagoras, the whole word. I can't fit the whole word in there, but you have to write the whole word, please. So you're missing an O-R-A-S there. Please add that in. Now you can write down what that answer is. You don't actually have to. I am going to write down what it is. It's 1,600. But you can leave that step out. Okay, you won't lose a mark. You can just do it on the calculator. And then to get AC, you have to square root that. Now the square root of 1,600 is 40. Right, so AC is going to be 40 millimeters. I'm going to put that 40 in on my picture in red because we've just calculated that now. Right, now we need to calculate the length of AB. Now guys, we have AC is 40, and in the beginning we've already filled in that these two parts are equal to each other. So that one is 40, that one is also going to be 40 as well, right? So what is the length of AB going to be? Remember, AB is now the whole chord, 80. And now your reason for that, guys, is line from center perpendicular to chord. That's how we know that those two parts are equal to each other. Because we have that line that's perpendicular to the chord, it cuts that chord in half. So if that half is 40, the other half is also going to be 40. Right, you could have put in an extra step if you wanted to, where you wrote BC equals 40. Then you would put your reason next to that statement. And then you would say, therefore, AB is 80. Okay, but you don't, you can do it all kind of in one step. Does that make sense, guys? So now these two theorems that we've learned today have nothing to do with angles. Alright, the theorems that we've practiced so far were all about how you find angles in circles, right? Angle at center, angles in same segment, all of those. Just remembering now, we actually did have some questions to mark as well. We'll do that next week. Alright, so for number 2, let's quickly do this one together. O is the center of the circle. BD is perpendicular to OM. There we have that again, guys. If the chord and the line from the center are perpendicular to each other, what does that mean? The line is going to halve that chord, bisect the chord, right? Cut it in half. So those two parts must be equal to each other. So look now what they're telling us. BD is equal to 24. The whole chord is 24. So what does that mean? The two halves are going to be 12 and 12. Now, when we use that 12 in our calculations, we have to put as the reason line from center perpendicular to chord. Okay, we can't just use the 12. We have to say why that part is equal to 12. And OM is 5. Now they want us to find the length of MD. Okay, we've actually already written that in, hey? So that's an easy question. MD is equal to 12. And I'm just going to write units. It's always a good idea to add units to your answer if it's a length that you're calculating, because they didn't say centimeters or millimeters or whatever here. And now your reason is line from center perpendicular to chord. Yes. It depends. Sometimes there's one question in a test where they decide to take a mark off if the units aren't there. So yeah, just try to remember. All right, now we must find OD. What am I going to do for that? Pythagoras. Okay, so OD squared. Now guys, in this case, do we agree OD is the hypotenuse? So I'm going to square the other two and add them together. So I'm going to say 5 squared plus 12 squared. Now I'm able to fit in the whole word. So Pythagoras. All right, so if you calculate that, it is 169. So then the square root of that is going to be 13 units. Okay, any questions on these two, guys? I would like you to do number 3 on your own for homework. I'm just going to give you a hint. So in number 3, they're telling you O is the center of the circle. MP is equal to 80. So there they've given us that whole length, right? Now guys, do we see? Can we pay attention, please? We can see that this line is perpendicular to the chord, so it's going to cut the chord in half, right? So if the whole chord is 80, what is MN going to be? 40. And NP is also 40. Oh, they're even telling us that. They didn't have to tell us that, right? We could see that from the theorem. But now they're also saying that NO is 40. Now they want us to calculate the diameter of the circle. What do we think we're going to do there? Yeah, so we can construct a radius there, right? Or on the other side, OP, either way. And then you can use Pythagoras to find that length. Is that right? And then what do you do with the length of the radius if you want the diameter? You're going to times it by 2. Okay, so that is your homework for Monday, guys. You have 4 whole days to do this question. But also